Without further ranting, I invite our most respected Dr. M.K. Ravi Varma sir, our speaker for the session on track engineering physics. He is a professor at Department of Physics from the prestigious institution, National Institute of Technology, Calicut. His academic career is decorated with several reputed awards and funding. His research interests include spectroscopy, development of instrumentation of atmospheric and environmental monitoring. Sir, it is our pleasure to have you here today in this session. The session is all yours. Sir, could you please unmute?
Yes. Am I audible now?
Yes, sir. Good to go.
Okay. So, oops. Okay. So, I think I'm given 10 minutes to present what is engineering physics is all about. And I gather that I'm addressing class 11 and 12 students mostly. So I'll try to put it in the simplest possible manner. What is engineering physics and what are the prospects that we are looking for. So my outline will be what is engineering physics, why engineering physics, and most of you would probably like to know, is it a popular one? We have been studying physics for so long, and what is the scope of engineering in physics? So, and the most importantly, if I study engineering physics, do I get any jobs? Then I will go into the difference between engineering physics and regular physics, and what is taught in engineering physics. And up to this point, it is mostly general. And then towards the end of the talk, I would speak a few words about engineering physics in NIT Calicut and what is the Department of Physics is all about. And finally, I will show I will show a few places where our students are now. So, what is engineering physics? Engineering physics is a relatively new stream of engineering. It started, the first batch started only in the 80s at University of Illinois Urbana-Champaign, if I am correct. University of Illinois Urbana-Champaign, and the reason for having they start engineering physics is that there are physicists, people who study science but have no skill of developing into a product or a design a product that is related to this. And then there are engineers who study purely design and development and prototyping and stuff like that. But as you know, that most of the traditional engineering has its underlying principles from physics. And then while engineering has grown, physics also has grown on the other side. For example, if there is a scientific instrumentation that need to be developed, then there is a science behind it, spectroscopy behind it, for example, a spectrometer, spectroscopy behind it, and then there need to be a product development. So there need to be an engineering skill translating the science into a product. So there is a bridge between science and the product. So they based on the industry needs, industry need to acquire scientists separately, engineers separately, and train them in both. So they found that it is not as productive, and they wanted institutions to impart this training and bring them out. I think that is the rationale for beginning, but it only happened recently. So physics is a basic natural science. We all know about it, and you studied it until this point, and you studied it for your entrance examinations and all those things. Physics is studying, it is all about fundamental forces and interaction between energy and matter. And then there is applied physics. Now, applied physics need not necessarily be engineering. It's just the application of physics. But applied physics is between physics and engineering. So engineering physics is an applied physics in that sense, and with engineering skills focusing on application, they target some high technology industry that required a good scientific understanding behind it. So more knowledge of modern physics with a little bit of skill in engineering is what was intended in the beginning. So why engineering physics? Students go into traditional engineering streams are exposed to fundamental classical physics until what you learn in +2 and your first year of engineering, which is not much more than your +2 level physics. Then you might take some physics courses based on your area of interest or based on the stream of the engineering that you study, but not much. So what happened is that when a lot of products have came about, engineers have built a lot of instruments that was used by physics people or science people in general, and they have actually improved physics to further level into applied physics, and then it eventually it pushed the engineering a little bit further because the need of the hour. So for example, a simplest example I can quote here is the transistor. It's a semiconductor material. It's developed from a semiconductor material, a semiconductor physics, and the person who developed the transistor got Nobel Prize, right? He was a physicist. He got actually, in fact, he got 2 Nobel Prizes, one for superconductivity and one for transistor. So you see, transistor originated from physics. Now it has moved into electronics engineering, and they have developed it further into further applications. It came back, and then something else was developed, and so it's a cycle. So there needs to be a bridge between science and engineering in any case. So engineering physics is meant to develop engineers with a sound grasp of physics. So that is, again, that is the fundamental idea. Now, when I said all those things, I can quote another example. Fundamental knowledge of you see, suppose we can buy lasers, yeah, right? Lasers we can buy, we can apply lasers, and then lasers have become important tools to advance research and development in most of the physics and spectroscopy and optics related fields. Now, even medical fields, right? How was laser invented? To know about the operation of laser, you need to have fundamental optics, background in statistical physics, a little bit of quantum mechanics maybe. It depends on the kind of laser you want to work with. So if you want to develop laser and spectroscopy into future, you need to know all these fundamentals of physics and a little bit of an advanced modern physics background. Then translate that into product. So that's one of the example I always like to quote for people. So engineering physics prepares students to apply physics to tackle 21st century engineering challenges and to apply engineering to address 21st century questions in physics. This is not my words. This is taken from Stanford University website. So is engineering physics popular? Now, engineering physics is now pretty much everywhere. So as it is originated in the USA and most popular in the USA because scientific engineering and scientific instrumentation and all these advanced technologies are mostly based in the USA. Everyone else copies from there. So in the USA, currently most major universities run engineering physics program in addition to traditional UG programs in physics. Now there is a difference between physics UG program in India and the physics UG program in the US. In the US, all UG programs are 4 years. So there is a pure BS in physics and BS or BE in engineering physics. So BS in physics, people will learn a lot of humanities and languages in addition to the basic core physics. Now, engineering physics people instead they learn a lot of engineering topics like engineering drawing, basic electrical, basic electronics, things like that instead of other humanity subjects, unless they are taking a minor in those. And the core of the physics are 80% the same. 20% difference maybe there, depends on the focus of the program and going for the advanced side. And people who want to go for theoretical physics, then I mean, as some of you may already be, and as we have seen some of the students who already came through our institute and left, we can see so many students are fascinated by the astrophysics phenomena or string theory or fundamental forces in nature or gravitational. One of our first student actually was taken part of LIGO experiments in Caltech. And he's now a postdoctoral fellow in Max Planck Institute. He is one of the co-authors of that LIGO experiment, the gravitational theory. And you know that gravitational force is the one last force that is not in the universe. I mean, it's not very well understood and it is not unified. All other three forces are unified. So that kind of thing. So those who want to go into such, if they are mesmerized with theoretical physics, we would suggest them to move to scientific science, BSc or BS in physics. But then there are other fields like optical engineering, photonics crystals, material science, nanotechnology, a lot of other fields, yeah, fiber optics, thin film technology. So those also need a lot of basic understanding in physics, and we could tune them to such a thing. So if you simply look at places where they have recently started engineering physics, you can see all the top universities are there, private and public: Stanford, Princeton, Harvard, Cornell, Illinois, Berkeley, a lot of them. And they actually distinguish their science stream and the engineering stream of the physics. And they already, the Stanford University is actually hosting an engineering physics interdisciplinary committee website. If you search on the web, you will find it. Don't just type EPAC, because EPAC also means EPIC. So you can write EPIC or Engineering Physics Committee of Stanford or something like that, you will get it. Now, coming back to India, it is starting to be popular in India also. When NIT Calicut started engineering physics in 2009, I think we were the fifth institute to start that. And now, as of last year, I don't know if any institute started this year, but in India, there are 13 institutes. There are 9 IITs, which includes IIT BHU and IIT ISM Dhanbad. 2 NITs, one is our own NIT Calicut, and NIT Agartala has recently started. Delhi Technological University had it before we started it, and recently Bennett University, it's the Times University, it is in Greater Noida. They also started engineering physics. So there are 13 institutes in India that have started engineering physics. Now, where to go after engineering physics? That is probably the question that you might have in mind foremost. So to tell you that, I have to say that with the background, with about 30 students that we intake every year, we have seen 25 of them complete the program, of which 10 students actually go for higher studies invariably. They are not even bothered about something. And then about 5 to 6 students, sometimes more, get into campus placement. But I have to say that in India, there is no base in scientific instrumentation, or even fiber optics or integrated photonics, or any such industries are not available. So core company job sectors are very less. Having said that, now many of those scientific instrumentations like Bruker Optics or Perkin-Elmer, so they have, or companies like that, they are having offices in India, and they employ them as in a technical capacity. Right now, they hire mostly MSc Physics students, and they do tend to prefer somebody with an engineering background. So we take engineering physics, and of the 13 universities, we have about 500 students graduating every year, and I would probably think that about 50% of them opt for higher studies, because I want to emphasize here that this is not a field that you just go if you don't get admission into other engineering stream, because you have studied physics so far and there's much more physics to learn, and it's not a simple subject to learn and pass, and then you end up having no interest in it. So I would say that if you have some aptitude in physics, if you have some interest in physics, then it can take you to places. And in university job industry, if you search, you can find that those who are very successful, actually you can find those salary levels in the EPIC website. That's why one of the reason I posted that in this discussion. So quantum physics and application, optics, photonics, spectroscopy and instrumentation. Actually, I in my research area is also there. Then medical and biophysics, space and aerospace, materials, semiconductor, nanotechnology, thin films, nuclear science and engineering, renewable energy, weather and climate, what happens if CO2 is doubled, the effect. Some computational simulation also is there. Then you can go into management, policy, law, for example, IPR law, and also into government sector. So when you go into such a program, what you expect to learn? So the core of the program is firm foundation in physics and mathematics. Without that, no engineering physics. So you have the freedom to choose from a diverse range of technical options. Many institutes design the program between physics and a traditional engineering department. So if you look at Stanford University, the engineering physics program, the BS physics is within the physics department, but engineering physics is under the Faculty of Engineering program. Faculty of Science is usually with the Faculty of Science and Arts and Liberal Arts and Humanities, it goes like that. So Faculty of Engineering and under Mechanical Engineering. So it's a collaboration between, it's not under Mechanical Engineering, but it's a collaboration between physics and mechanical in Stanford. If you look at IIT Madras, it's a collaboration between physics department and electrical engineering. So, but many institutes, they stay within the physics department, but with the collaboration of other engineering departments. So courses are shared, and depends upon the interest that students take. In NIT Calicut, the scenario is like we hope we do actually find some of them, like the person I mentioned about the Lego experiment. So he joined NIT Calicut engineering physics despite having obtained other branches in IIT Madras. But he was determined. So such a student can always go to places. First and foremost, your interest matters. If you have interest in any particular stream, go for that. That can take you to more heights. The first year of the program is common to all engineering streams. This include basic sciences and engineering, like physics, chemistry, life sciences, electrical sciences, professional communication, engineering drawings, workshops. So first year is common to all engineering stream. And later on, there are other common subjects also with common to other engineering programs. They are principles of management and economics. So within the department, we teach all modern physics courses, everything up to our MSc level. So classical mechanics, statistical and thermodynamics, actually. Statistical mechanics, it's kind of, you can consider it as an advanced thermodynamics science course, not an engineering. Quantum physics, we have 2 quantum physics courses, basic and advanced. And then electromagnetic theory, we teach 2 courses, basic and advanced. And we have optics course, atomic and molecular physics, nuclear science and engineering, material science, and photonics. We have corresponding laboratory courses, and we have computational physics courses related to that. Then, as students learn physics, they tend to show their interest. Some people are really highly mathematical oriented. They take a lot of advanced courses, even courses for MSc and PhDs in mathematics department. Some of them get interested into fluid dynamics and fluid mechanics kind of courses. Some people interested in electrical, biomedical engineering kind of courses. So it depends on them. Some students take computer science courses like quantum computing. So they are included as elective courses. So there are a total of 7 elective courses, I believe, of which 2 courses can be taken from other departments, and sometimes we allow to take more than that. What do they do during their studies? They go for internships, industrial training, and mini projects as per the curriculum. And we had some collaboration with some foreign universities where we did send some 13 students recently in 2 years, but that program is not there anymore. But we are trying for other thing where we can expose our students to. Students can do the major project in other departments or even national labs. Students do their projects in astrophysics or theoretical physics, string theories, or there are most of the basic physics related projects are available in the department, but some people go outside. Some people go to, 1 or 2 students always go and do their projects in mathematics department. Some of them goes to nanotechnology department, which is now School of Material Science and Engineering. So this is all about engineering physics background, scopes, and what is taught. Now, talking about my department, Department of Physics, it was established in 2009 in NIT Calicut. We got a lot of fundings to establish our laboratories and research, and recently from DST and FIST funding for getting some instrumentation. So we don't have MSc Tech anymore, but we have MSc in Physics. MSc Tech started in 2008, but now it is MSc Physics. Now we have BTech in Engineering Physics that has an intake of 30 per year. Starting year is 2009. Then we have PhD program in physics. We have experimental, theoretical, and computational physics, and we have 16 permanent faculty now. For if we have more courses, then we take ad hoc or contract teachers. So you can see that we have 32 PhD students, 38 MSc students. As of last year, we had 111 BTech students, but some of them already left. So you can see that our intake is very less. So our faculty to student ratio is quite good, and we take individual personal care. We could do that. It's probably not possible on a large scale if you have 150 to 170 students incoming. But I'm not saying that is a huge advantage, but sometimes it is it's an advantage. So we offer applied engineering, global electives like optical engineering, fiber optics, etc., for other department students, which is taken mostly by electronics and electrical engineering students, and then that is taken by our students too. That's about my department. We have a lot of students everywhere in the world. I'll come to that in a second. I want to mention here that 2 BTech students have started entrepreneurial I don't know, startup companies. One is Quill Tech. He developing a 3D pen. He just passed this year. There is another one called Jalayantra, some engine to be powered by water. And actually, there is one more thing. One of our erstwhile BTech engineering physics student has joined with a mechanical engineering student and now started a robotic physiotherapeutic instrumentation startup. We are actually incubated this in our incubation center in NIT Calicut. Then many of our students get Erasmus Mundus, at least 2 every year goes to Europe under Erasmus Mundus scholarship for masters. Then Marie Curie, we had the students going with Marie Curie. But for Marie Curie, you need a master's with you. So we have 2 students went to Canada under MITEX fellowship, this summer fellowship. Then there are other faculty include a lot of experience and awards and etc. So looking at general research focus. We have photonic materials. We have three faculty in photonic materials. We have soft matter physics. You can see that some of them are in a different field also. So we have thin films, we have material science, organic semiconductor, we have energy materials, we have atmospheric physics and climate, also spectroscopy. Then we have theoretical physics, string theory, and that theoretical physics includes theoretical condensed matter physics and computational physics, and then we have nanomaterials. We have a lot of research and development here. I'm not going to go into that. Placement details, I've already talked about that. No core industrial sectors in India. Most of our students, top students, prefer to go for higher studies and abroad. So these are first batch students went to Indian Army and PhD abroad, and some of them are employed abroad already, and one person is already employed in Max Planck Institute. We have 2 startup companies from the following batch. Lot of things. I don't want to explain all of them. And thank you for your attention. I will answer any specific questions you may have.
Thank you so much, sir. I request Mr. Sriram to moderate the Q&A session, if any.
Thank you, Varma sir, for your wonderful session regarding the details of physics. And there were some questions in the query, but I think most of the questions were already answered by you during the session.
Okay.
Okay, there is only one question pending. When compared to other engineering branches, what's the scope of having a campus placement in engineering physics, or we have to go search for it?
Campus placement, they are allowed to, I mean, if you don't have any backlogs, they are allowed to sit in the campus placement, and they do get into places, but they are not core in the sense that fiber optics is a core. There's no fiber optics company that is going to hire in India. Yeah. So like that, they can go, and many of them have gone into financial sectors. A couple of them have been employed in Byju's, you know, Byju's app, right? And people have gone into software sector. So that is, I didn't mention it because it's not core of our program, but they are eligible to attend to the interviews.
Thank you, sir, for your time. Back to Anamika.
Thank you so much, sir, for acknowledging and enlightening us with immense knowledge on this session. I extend my sincere gratitude for joining us today as our speaker for the session. Thank you.
Thank you.